Okay, so we were doing the questions on this sheet, momentum and conservation of momentum, and we were on number 5 when the last video ended. So it's a bullet of mass 0.05 kilograms moving at 400 meters per second. So VI is 400 meters per second. When it encounters, and that should be a retarding force of 3,000 newtons. So F is 3,000 newtons. Right? A retarding force is a force that slows it down in the opposite direction. Right? If you're trying to retard my motion, it means that you're putting obstacles in my path to slow me down. So I'm putting a negative on this 3,000 newtons because I know it must be in the opposite direction of that 400 meters per second. Okay, continuing to read, it wants to know the time required to stop the bullet in part A. So to stop the bullet means VF is 0. Okay, and so we're looking for the time. So again, F delta T is equal to M delta V. So delta T is going to be equal to M VF minus VI over F. So delta T will equal 0.05 kilograms. This goes to 0, so negative 400. So that should be 20 on the top. And on the bottom, negative 3,000 newtons. And if you didn't put the negative in here, the 3,000 in is a negative, you didn't pick up the retarding piece, then you would end up with a negative time and something would definitely be wrong. Okay, so you end up getting 0.006 repeating seconds. So 6.6 times 10 to the negative 3 seconds. There is a part B that says, find the distance the bullet traveled. Well, we have a VF, we have a VI, we have a delta T. We could find an A. A is equal to VF minus VI over delta T. This goes to 0. A is equal to negative 400 meters per second over a 6.6 to the negative 3 seconds, and keep the repeating. A is equal to times 400, 60,000. Wow. 60,000 meters per second squared, and it's negative. And then you would go to, I would go to, if it's looking for distance, delta D is equal to VI delta T 1/2 A delta T squared, or you could do VF squared equals VI squared plus 2A delta D. The advantage of this one is you don't have to rearrange it. So it'll be 400 meters per second times that 6.6 times 10 to the negative 3 seconds plus 1/2 60,000 newtons and 60,000 meters per second squared, and don't lose your negative, times the 6.6 times 10 to the negative 3 seconds. I lost, and then that's squared. I ran out of room over there. Okay, so negative 6,000 times 0.5 times the 0.006 squared. The second term becomes a negative 1.3 repeating meters, plus brackets the first term, 400 times the time, 2.6 repeating meters. And so delta D is equal to 1.3 repeating meters if you don't round your time at all. Okay, so that's number 5. All right, 6 and 7 get into the conservation ones. So number 6 says, small red card of mass 2 kilograms is traveling west. So it's over here, mass 2 kilograms, and it's traveling west. So V1 initial, 4 meters per second, west. When it collides head on with a blue card of 5 kilograms, so here's my blue card, 5 kilograms, it's traveling east 3 meters per second. So V2 initial is 3 meters per second east. They remain stuck together after the collision. So they get entangled during the collision, and then they're going to go off some way. We don't know which way, but they're going to have a VF, and it's going to be the same. So we go to our conservation of momentum equation that we just learned, m1v1 initial plus m2v2 initial will equal m1v1 final plus m2v2 final. But these two v finals are the same, so we could actually pull the vf out, and it would be m1 plus m2 in brackets. Over here still m1 v1 initial plus m2 v2 initial. Part A of the question wants this common velocity, so divide by m1 plus m2. So vf will equal m1 v1 initial plus m2 v2 initial divided by m1 plus m2. And now fill in your values. M1 was 2 kilograms. This guy was number 1. 2 kilograms, and it was traveling west, and the other one was traveling east. So we have to call some way negative. So I'm going to call west negative. So negative 4 meters per second plus M2 was 5 kilograms. And it was initially traveling east 3 meters per second. And then you're going to divide that by 2 kilograms plus 5 kilograms. Okay, so on the top you have negative 8 kilogram meters per second plus 15 kilogram meters per second, and on the bottom 7 kilograms. So you end up with a VF of 7 kilogram meters per second over 7 kilograms. And so VF equals 1 meter per second. It works out to be positive, which means it's east. Okay, so that's number 6. Number 7. A 4,000 kilogram truck traveling east. Okay, so 4,000 kilograms, and it's traveling east 8 meters per second. So V truck initial is 8 meters per second east. When it collides with a 2,500 kilogram car traveling west at 6 meters per second. So 2,500 kgs, and V car initial is 6 meters per second west. Oh, I forgot part B and number 6. Okay, I'll go back to it in a second. And then it says find their common velocity after the collision. So again, M1 V1 initial, or M truck, plus M car V car initial will equal M truck V truck final, M car V car final, but the two V's are the same, so pull them out, just call them V final, M truck plus M car. And on this side, the same thing. And now you're going to divide both sides by the bracket. So M truck plus M car, and then fill your numbers in. So VF is equal to 4,000 kilograms times 8 meters per second, calling east positive, plus 2,500 kilograms times negative 6 meters per second over 4,000 kilograms plus 2,500 kilograms. Make the math easier. I'm canceling a set of zeros. VF should end up equaling 2.62 meters per second. Works out to be positive, so it's east. Okay, going back up to 6B, we have a minute. It says, what is the impulse on the red car? The red car was this guy. And remember, impulse, J, can be equal to M delta V. So J is equal to MVF minus VI. So the red car's mass was 2 kilograms. The final velocity of the red car was 1 meter per second east that we found. And the initial velocity was 4 meters per second west, so minus a minus. So inside the bracket is 5, right? 1 plus 4 times 2 is 10. So 10 kilogram meters per second works out to be positive, so it's east. And that should make sense that the impulse on the red car would have to be east because it was traveling west and then it turned around. So the impulse must have been big enough to slow it down, stop it, and turn it around. Okay?